Hello and welcome to a very quick presentation about Libre-SOC. Libre-SOC is a 3D hybrid CPU, VPU, GPU intended for mass volume use in netbooks, smartphones, tablets, Chromebooks, and industrial IoT. It is unlike anything else that's ever been attempted before in the Libre open world. This is a different style presentation. I'm just going to use some links online to show you what we're doing. So here is what we have. It's our main page. We have a status of the tasks that we're doing. All of these are sponsored by NRNet. We have a floating point library, a Kazan 3D driver, a Mesa 3 driver, some bit manip instructions that we're going to be doing, cryptographic router ASIC, video instructions. It's a huge job, and the critical part is vectorization, which we're being kept an eye on by the Open Power Foundation. We'll be submitting this upstream to the actual Open Power ISO working group for inclusion in the power instruction set. So this page shows the progress we're making and describes a little bit about what our goals are. I have some experience in manufacturing of circuit boards and product design, so it's targeted these particular specifications are targeted easy manufacture for mass volume to keep costs down for products. This is a page showing the peripherals that we're going to be adding. They're exactly the sorts of things that you would find in a tablet processor or a smartphone processor. So really quite basic. We're also looking at doing what's called a PowerPi processor, which will be in 22 or 28 nanometer. It's pretty much exactly the same as the other one, but we put online what the costs involved. The total manufacturing cost for this in 22 nanometer is about $7 million. And here's a list of what the functionality is, which is the same as on the previous page. Now, why are we doing this? Why are we going to all the trouble of creating an entirely new processor? Here's why. 40% of smartphones contain a vulnerability. Right? That's all smartphones and tablets found using worldwide, which is 40% of the market. All those smartphones are vulnerable to attack. If you think that that's not been used, it has. Okay. In addition to this, I've discovered recently from Dr. Stallman that somebody installed Replicant on their smartphone, went to a foreign country, and just by registering on an international network in that country, by international roaming, their entire operating system was replaced with a standard Android plus spyware by the government of that country without their consent onto their own phone. The Intel Management Engine, introduced in 2006 in every single processor ever since, has massive backdoors. All Intel chips are open to a non-Spectre style attack, and I could go on forever like this. All right, it's not. These are recent things. This one was March the 5th. This report. The Qualcomm one was May the 7th. All right. It's just going. It's on and on. It's a never-ending thing, and these people are not acting responsibly. All right, they can't. These are big companies. This is Intel, Qualcomm, Apple. All right, the one with this. Well, this one was with an Apple, a drive-by firmware upload. Now, there have been other projects that have been funded by the European Union. Think Selenium in fact is based in Greece, and so received grants in 2016. I contacted them, asked them what are you doing. I'd like to help because obviously this is a big project, and you're working on LLVM compiler. I just did not receive a single response from the developer. So they then presented a RISC-V instruction set modification for the 3D GPU, and that was as March 26th of this year. May the 4th, they announced that they've been bought by acquired by a United States-based company. So all of the funding that was European Union funding that went into that, where they were expecting to be benefits to European EU companies, is now gone to the United States. By contrast, all of the source code of what we're doing is publicly available. We can't back out of that decision. All right. You can see here, this line here was committed 84 minutes ago. We made a commit to the simulator, which we're doing for the Open Power Instruction Set. In addition to that, we're using Coriolis 2 from Sorbonne University in France. So even the chip itself, the processor itself, you'll be able to verify it down to the bedrock and replicate the GDS2 files, as they're called, to check that they're actually working. And the important thing about this software is it's all GPL licensed as well. Not only that, we're collaborating with Chips for Makers. Chips for Makers is offering the ability for open hardware and Libre hardware teams to bring to processors to market, and it's extremely affordable cost. 50 chips in, admittedly this is 360 nanometer. 50 chips is only 1,750 euros, which is fantastic. And also here, staff is also doing a free PDK, a cell library, which you can use the academic free PDK 45 with Coriolis 2 to do your layout. Absolutely everything we're doing is Libre license, and we're also doing formal verification of things. So thank you very much. Any questions?